Look up on a clear night, and you'll see them. Stars, distant shining beacons scattered across the sky. They look eternal, unchanging. But in truth, every star has a story of birth, of transformation, of death, and rebirth. This is the life cycle of stars. All stars begin their journey in the same place, a nebula. These vast clouds of gas and dust drift through space for millions of years, seemingly quiet. But within them lies the potential for greatness. As gravity begins to pull the particles inward, they clump together. These clumps grow dense, their cores growing hotter and hotter. Eventually, a new object forms at the heart, a protostar. It's not quite a star yet, but it's on its way. At this stage, the protostar is gathering mass, pulling in more material from the nebula around it. Deep inside, pressure builds, temperatures climb, and then something miraculous happens. Nuclear fusion ignites. Hydrogen atoms begin to fuse into helium, releasing enormous energy. This marks the star's true birth. It has entered the main sequence. Now the star settles into the longest phase of its life. Hydrogen fusion in the core creates a perfect balance. Energy pushing outward, gravity pulling inward. This balance can last for millions, even billions of years. Our sun is currently in this stage, a middle-aged main sequence star, quietly burning hydrogen and keeping our solar system alive. Not all main sequence stars are the same. Small red dwarfs burn slowly and can live for trillions of years. Massive blue stars, however, burn through their fuel quickly and then die young. But nothing lasts forever. When a star's hydrogen runs low, the core begins to shrink. The outer layers, however, expand. The star becomes a red giant, swollen, cooler on the surface, but fierce and unstable within. New fusion reactions start, helium into carbon, and even heavier elements for the most massive stars. But this stage is turbulent and short-lived. What happens next depends on how massive the star is. For stars like our sun, death is gentle. They shed their outer layers into space, forming a glowing shell of gas called a planetary nebula. At the center, only a small, hot core remains, a white dwarf. This white dwarf no longer produces energy. It simply glows with leftover heat, slowly fading over billions of years. Eventually, it becomes a cold, dark black dwarf, a silent remnant in the universe. But massive stars go out with a bang. When fusion stops, the core collapses in less than a second. The outer layers rebound off the core and explode outward in a cataclysmic supernova. For a brief moment, one star can outshine an entire galaxy. This explosion hurls elements like carbon, iron, and gold into space, the very building blocks of planets and life. After the explosion, the core that remains can become one of two incredible things: a neutron star, unimaginably dense, spinning rapidly, with a magnetic field stronger than anything else in the universe. Or, if the original star was massive enough, the core collapses further into a black hole, a place where gravity is so strong not even light can escape. What lies inside? No one truly knows. But this is not the end of the story. The gas and dust blown out by dying stars returns to space, and sometimes it becomes part of a new nebula. New stars are born from the ashes of the old. It's a cosmic cycle, destruction giving birth to creation. Stars make elements, elements make planets, planets make life, and life, like you and me, is made from stardust. So the next time you gaze at the stars, remember, you're not just looking at distant suns. You're witnessing time itself, the past, the present, and the future of the universe, written in light. Because stars don't just shine, they live, they die, and they create the universe we call home.